Good evening, sir.
Good evening, madam. Good evening.
Sir, we'll start at sharp 6, sir.
Okay, madam.
Training.
Okay.
Yes, sir.
Unmute.
Yes, madam, should we start?
Yes, sir, you can start, sir.
Okay, madam, thank you. So, good evening, students. So, last class we discussed regarding with respect to principal stresses and principal strains. So, in this class, we will just move on to few of the things like how to compute principal stresses as well as its inclined plane and all. Okay. So, in last class, you're having any doubts? In last class numerical, or you're having any doubts? Shall we proceed with
Sir, one sorry, revised ಮಾಡಿ sir.
Okay, pa. I will do. So if you are
Hello,
having
sir.
any specific doubts, please ask me.
Hello.
Yes, we will do.
Okay, sir.
Okay. So let me move on to the principal stresses. I will try to glance once again the topic and then I will move on to the next topic. Okay. Okay. So what is mean by principal stresses and principal strains? So generally the principal stresses are the stresses which acting, there is no shear stresses. There's only pure normal stresses. Then the plane is called principal plane. On that particular plane, the stresses acting, those stresses are called principal stresses. Okay. Generally the compound stresses. What is meant by compound stresses? It is the combination of both normal and shear stresses. So what are the stresses on inclined plane? That is very, very important. In last class, I just explained regarding this. So if there is no shear force, then obviously we can expect, if there is no shear force, we can expect the shear plane only this phase. But in this diagram, there is a shear. Because there is a shear force, then obviously this is not our principal plane. The principal plane should be inclined with respect to vertical inclination. So that's why somewhere in the material, there is a principal plane. AC is the principal plane for these kinds of compound stress system. But if there is no shear stress, then obviously the phase, whatever the perpendicular phase, that is the principal planes. So this is the analytical formula to compute the normal stress as well as tangential stress. Normal stress, this is the normal stress. This normal stress can be computed using this equation, sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. So generally we are notating as sigma n or sigma theta. Both are same. Don't confuse with the notation. Sigma theta as well as sigma n, both are same. And also you are having one more equation, that is tau theta, that is tangential stress on this plane. This is also referred as sigma t, tangential stress, sigma t. The sigma t is sigma x minus sigma y sin 2 theta. Here there's a missing. This is also sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 sin 2 theta minus tau xy cos 2 theta. So these are the two equations you have to remember. Generally, they will ask this particular thing to compute normal stress on the inclined plane. So, but very, very important thing is this one. That is principal stresses and principal planes. Please practice the equation because you are getting numerical in the examination. Generally, they will ask numerical. So what is mean by principal stresses and principal plane? So I already explained that is the principal planes are nothing but where you can expect the principal stresses here. If you are having, see, 1 minute. I will take workout working slide. Okay, this is best. Yes. See, you know that generally if in the system, if there is only normal forces, then which is your shear plane, which is your principal plane? This, for this sigma x, this is the principal plane. For sigma y, this is the principal plane. But what is meant by compound stresses? This is not a compound stress. This is a normal stress. Compound stress, it means compound stress is the combination of both normal as well as shear stresses. So if it is sigma x, here you are having sigma x. You can, it may be tensile or compressive, whatever it may be. Away from the force is referred as tensile, and towards the force is referred as compressive. So this is compound stress. You are getting a pair of shear stresses on the surface also. You are having tau xy or tau yx also. So this particular system is referred as compound stress. Compound stress. So in compound stresses, where in this particular normal stress, the principal plane itself, the face itself, principal plane. Why? Because a principal plane is nothing but there is no shear stresses. If you observe the diagram 1, there is no shear stresses. No shear stresses. So if there is no shear stresses, therefore the principal plane, this is the principal plane. This is the principal plane. Principal plane. But in this case, this is the case 2. What is happening in this case? There is a shear stress on the face. There is a shear stress on the face. Just observe here. There is a shear stress on the face. In this kind of force system, in this kind of segment, where we can expect principal plane. Where we can expect principal plane. Principal plane you may expect somewhere inside the element with respect to angle of inclination theta with respect to vertical. For this kind of forces, this is the principal plane. This is the principal plane. So on this principal plane, I will take it as separately now. On this principal plane, there are two forces. One is sigma n, that is normal force. Another one is sigma t. This is referred as sometimes sigma theta, and this is referred as sometimes tau theta. Both are same, don't confuse. Okay, so this is the normal stress and tangential stress acting on a principal plane. Acting on a principal plane. So this is this thing you must remember the equation. What is the equation? Yesterday I have given the equation. What is the equation? Try to give that equation. Sigma n equals sigma x plus sigma y by 2. Please try to recall the equation. Plus sigma x minus sigma y by 2 into cos 2 theta for sigma n cos 2 theta plus tau xy sin 2 theta. Here sin 2 theta. But for tau t or sigma t, the only change is cos 2 theta will become sin 2 theta. Sin 2 theta will become cos 2 theta. That's all. Clear? Okay. So this is purely associated with the analytical equations. Analytical equations. This is the first thing you have to remember. Very, very important case. That is, what are the stresses developed on the principal plane? There are two types of stresses are developed on the principal plane. That is normal principal stress, tangential principal stress. But on principal plane, you are having two more stresses. That is major principal stress and minor principal stress. That is the second segment. You have to remember, this is also very, very important. This is also very, very important. What is mean by major and minor principal stress? Major and minor principal stress. Generally what happens on the principal plane, the stresses are acting. There are, see, how many normal stresses are there? How many normal stresses are there? You have to answer. In this figure, how many normal stresses are there? ಎಷ್ಟಿದೆ? ಇಲ್ಲಿ ಫಿಗರ್ ನೋಡಿ, ಇದರಲ್ಲಿ ಎಷ್ಟು ನಾರ್ಮಲ್ ಸ್ಟ್ರೆಸ್ ಇದೆ ಹೇಳಿ? 2. Very good. There are 2 normal stresses. One is sigma x, another one is sigma y. With respect to y-axis, so normal stresses are 2, sigma x and sigma y. How many shear stresses? Only one. That is, here there are 2 normal stresses, sigma x, sigma y. So with respect to these 2 stresses, you are getting 2 principal stresses. With respect to 2 normal stresses, you are getting 2 principal stresses. What are those? One is sigma 1, that is called major principal stress. Major principal stress. Sigma 2, that is called minor principal stress. These are the correspondings to 2 normal stresses. Don't confuse. Here, if you observe the system, if you observe the stress block system, you are having sigma y, sigma x, and sigma x. Correspondings to these pairs, sigma y is one pair, sigma x is a second pair. With respect to these 2 pairs, you are having one major principal stress and another minor principal stress. And also you may expect, what is another thing? Shear. You may expect shear. So that is called maximum shear stress. That is called maximum shear stress. That is called maximum shear stress. Maximum shear stress. Clear? Any doubts? So now this equation, what is the equation for major principal stress? Yesterday I have given the equation. What is the equation for major principal stress?
Sigma x plus sigma y by 2.
Very good. Sigma x plus sigma y by 2
plus
square root of
sigma x minus
sigma y by 2 whole square plus
tau xy
square. But what is minor?
Minus.
Yes, only thing is minus square root of sigma x minus sigma y by 2 whole square plus tau xy square. What is maximum shear stress? Sigma 1
minus sigma 2 by 2.
All are in MPa, Newton per mm square, or with any of the units. Nothing to worry about units. So these 3 are very, very important. With respect to this, these major and minor principal stresses are having inclination. So that inclination can be determined using equation. This is the thing you have to remember. This is also one more very, very important equation. This is the inclination of principal stress. Tan 2 theta equals 2 tau xy divided by sigma x minus sigma y. So please remember these 4 equations. These are all very, very important equations. Very important equations. So any doubts? Clear aitappa? Any doubts? Okay. Shall we move on to the next topic? Okay. Now, here, you just see here. This is the thing I have written. This is the thing I have written, that is tan 2 alpha 2 tau xy. So, next thing. Yes, this is very, very important thing. So, the value of shear stress is tau max equal. So, you just remember the second one. Sigma 1 minus sigma 2 divided by 2. That is the best. Or else, in the question, they are asking directly tau max. In that case, you have to remember the equation. This equation you must remember. That is square root of sigma x minus sigma y by 2 whole square plus tau xy whole square. This is the average shear stress. The average shear stress can be computed as major principal stress plus minor principal stress divided by 2. Sometimes they will ask in examination, what is the average shear stress, normal shear stress on the plane? They will give an option, sigma 1 minus sigma 2 by 2, sigma 1 plus sigma 2 by 2. On this case, you have to pick the average normal shear stress is sigma 1 plus sigma 2 by 2. So the next very, very important method, we will move on to this method, that is Mohr circle of stresses. This is very, very important. This plays a major role in your whatever. If you know Mohr circle, how to construct Mohr circle, you can play with this. Without knowing the equation, you can guess the answers for two-dimensional stress system. So Mohr circle is useful for finding principal stresses and maximum shear stresses. So these are the very, very important aspects. It is very much useful to finding principal stresses. What are principal stresses? What are principal stresses? Sigma 1 and sigma 2. Major principal stress, minor principal stress, and maximum shear stress, and tau max. So these three things are easily computed using Mohr circle of stresses. See, consider this case. Consider this case. How we are going to construct the Mohr circle. So here, how many forces, how many stresses are there in this particular system? There are, see, for this case, how we have to construct Mohr circle. See, I will explain. So don't see the presentation. We will move on to the working slide. We will move on to the working slide. I will explain how to construct Mohr circle in separate slide. Separate slide. Am I audible? Kedista idea?
Sir.
Yes, sir.
Okay. See, this is very, very important. Mohr circle. How to construct Mohr circle. See, consider any of the example, any one stress system. It may be both acting, both tensile or both compressive, whatever it may be. I will consider tensile, both tensile, or you may take compressive, no problem. Sigma y, sigma y. See, the ultimate aim, what are the things we have to determine? Major principal stress, minor principal stress, and maximum shear stress. These three things we have to determine using Mohr circle. Okay. So with this, we will take a pair of shear stresses also. A pair of shear stresses also. Tau xy and tau yx. Okay. So now, how to construct Mohr circle to find principal stresses as well as shear stress, maximum shear stress. This is very, very important thing. For this, generally in examination, what you will do, you are having graph sheets. You can play easily with the graph sheet, right? You know that. But here also, I will try to explain without graph sheet. So the thing is, majorly in any two-dimensional plane, what are the axes? What are the axes? Ordinate, that is ordinate y-axis, and axis are x-axis, right? X and y plane, right? X and y plane. You know that. So generally, what you have to remember, but in this case, the main thing you have to remember is, the very, very important thing you have to remember is normal stresses. Normal stresses are always plotted along the abscissa or along the x-axis. What are normal stresses? What are normal stresses here? Sigma x and sigma y. So if the values of normal stresses sigma x and sigma y are plotted along x-axis, you have to see if it is positive value, you have to plot it along first quadrant, right side. If it is negative value, you have to plot it along left side of the x-axis. So always plot along x-axis. The normal stresses sigma x and sigma y are plotted along x-axis. The next important point is shear stress. Shear stress tau xy is plotted along y-axis or ordinate. Tau xy or tau yx are plotted along y-axis. Now you just observe the given figure. This is the given figure. So sigma x, sigma x. See, I will consider this is x-axis. This is y-axis. Okay. Now you tell me sigma x is tensile or compressive? Which type of force this is? Tensile. So tensile. With respect to act, all acting away. Tensile forces are positive. What about compressive?
Negative.
Negative. Okay. See here, this is tensile. This is a positive value. I don't know the exact value. So what I will do, I will take approximately the value somewhere here. Okay. So this is sigma x, positive. Okay. One of the pair you have to take, whether this or this, you take tensile nature, one set. That's all, positive. Next, you just come to another stress part. So that is also tensile given. Sigma y. So what I told that these two are normal stresses. Where I have to plot normal stresses? On the x-axis only. If it is sigma x, say, is a higher value. Next, sigma y is also one value. That is also on the x-axis. Tensile positive. So any doubts? Say for an example, say take this is 50 MPa and take this is 10 MPa. Okay. Now, as per our graph, you just see the graph. I will try to plot the graph. Generally, your graphs are like this, right? So, sigma y 1, that is 10 MPa. You have to take 1 centimeter, which is equal to 10 MPa. Then this is 1 unit. So sigma y positive. This is also tensile positive. 1, 2, 3, 4, 5. Somewhere here. Right? Or you may take it, this is 30 for just minimizing the thing. So 1, 2, 3. Here, somewhere here, 3, third graph. Okay. So this is 30 and this is 10. Any doubts? This is 10 and this is 30. Any doubts? Any doubts?
No, sir.
Clear? So this is positive. Both are positive. If it is negative, then you have to plot on left side. Clear? Now I will consider the shear. Shear now. Say shear is around 40 MPa. 40 MPa. Both are same. Always I told that shear forces are same. See, this for shear, the sign convention is very, very important. See, generally, what is the sign convention? Here, this is a reverse sign convention. Clockwise forces are termed as negative, anti-clockwise positive. But you can keep, like, you can remember this thing. If you see this particular shear force, how it is rotating? Clockwise. Or what you have to do, the thing is, if the clockwise, you just see the upper face. If it is clockwise, you have to plot that value in negative ordinate. So the thing is, one is always one pair is negative and another pair is positive. One pair is negative and another pair is positive. You just see for sigma x, which is the shear force, this one. For sigma x, this is the 40 acting in which direction? Rotating in which direction? With respect to sigma x, how it is rotating?
Anti-clockwise.
Anti-clockwise. What is the sign convention for anti-clockwise? Anti-clockwise. Anti-clockwise is in Mohr circle. Anti-clockwise positive.
Positive.
Clockwise negative. Please, this is very, very important. While you are drawing Mohr circle, clockwise rotation is negative. Anti-clockwise rotation is positive. With respect to sigma x, how it is rotating? Anti-clockwise. So negative. So sigma x, you have to come to sigma x at 30. How much you are having? 40. So 40 means 10, 20, 30, 40. Somewhere here, right? So here sigma x, somewhere here, 40, right? This is sigma x comma tau xy. That is 30 comma 40. 30 comma 40. See this one. You have to join this one with a straight line. Clear? Next, for sigma y. So this is the sigma y. How it is rotating? 40. How it is rotating? For sigma x, it is rotating in anti-clockwise direction, right?
Yes, sir.
Wait. For anti-clockwise direction, what is the value? Yes, positive. Where I have to plot? On the upward side, because it is positive. Sigma x comma tau xy. This is 30 comma 40. Next, sigma y. How it is rotating? Clockwise. What is clockwise? Negative. So negative 40. Say here. This is sigma y tau xy. This is say 10 comma 40. 10 comma 40, right? So any doubts? Any doubts?
No, sir.
Now with the help of scale, you just join these two things. With the help of scale, join these two things with a straight manner. Scale itkondo neat join madrappa. Scale itkondo neat agi correct agi center cut agutte adu ನೋಡ್ಕೊಂಡು ಜಾಯಿನ್ ಮಾಡಿ ಆಯ್ತಾ. ನನಗೆ ಇಲ್ಲಿ ಸರಿಯಾಗಿ ಬರ್ತಾ ಇಲ್ಲ because I'm not using scale and all. Okay, try to do with the help of scale. ನೀಟಾಗಿ ಕಟ್ ಮಾಡಬೇಕು. We'll try. Okay, so this whatever, this is the origin. With the help of this, ನೀವು ಸರ್ಕಲ್ ಡ್ರಾ ಮಾಡಬೇಕು. ಇದನ್ನ ಆರಿಜಿನ್ ಆಗಿ ಇಟ್ಕೊಂಡು you have to draw a circle. You have to draw a circle. With the help of this, you have to draw a circle. Okay, that is the Mohr circle. See, so this circle is Mohr circle. Any doubts? This circle is Mohr circle. ಇಷ್ಟೇ ನೀವು ಮಾಡಬೇಕಾಗಿರೋದು. ಈ ಸರ್ಕಲ್ ಅನ್ನು ಯೂಸ್ ಮಾಡಿ how to compute sigma 1, how to compute sigma 2, how to compute tau xy. ಇಷ್ಟನ್ನ ನಾನು ಹೇಳ್ತೀನಿ ಇವಾಗ. So any doubts how to construct Mohr circle? ಕೇಳಬೇಕು. This is very, very important. It's in your syllabi. ಬಟ್ ನಿಮ್ಗೆ ಕನ್ಸ್ಟ್ರಕ್ಟ್
Sir.
ಮಾಡಕ್ ಕೇಳಲ್ಲ, ಅವನೇ ಕೊಟ್ಟಿರ್ತಾನೆ, ನಿಮ್ಗೆ ರೀಡ್ ಮಾಡ್ಬಿಟ್ಟು ನೀವು ಆನ್ಸರ್ ಗೆಸ್ ಮಾಡ್ಬೇಕು ಅಷ್ಟೇನೆ. ಬಟ್ ನಿಮ್ಗೆ ಕನ್ಸ್ಟ್ರಕ್ಷನ್ ಮಾಡಕ್ ಬಂದ್ರೆ ನೀವು ಆ ಈಕ್ವೇಶನ್ ಎಲ್ಲ ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋ ಅವಶ್ಯಕತೆ ಇರಲ್ಲ. ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ ಸ್ಕೇಲ್ ನೀವು ಒಂದು ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ ಹಾಕೊಂಡ್ಬಿಟ್ಟು ಇಮಿಡಿಯೇಟ್ಲಿ ಆನ್ಸರ್ ಗಳು ಬರ್ದ್ ಬಿಡ್ಬೋದು. ಸೊ ಎನಿ ಡೌಟ್ಸ್ ಹೌ ಟು ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಮೋಹರ್ ಸರ್ಕಲ್?
No, sir.
ಜನರಲ್ ಸೈನ್ ಕನ್ವೆನ್ಷನ್ ನೆನ್ಪಿರ್ಬೇಕು. ಟೆನ್ಸೈಲ್ ಫೋರ್ಸಸ್ ಪಾಸಿಟಿವ್, ಕಂಪ್ರೆಸಿವ್ ಫೋರ್ಸಸ್ ನೆಗೆಟಿವ್, clockwise moment negative, anti-clockwise moment positive. With the help of this I have drawn Mohr circle. First what I did, I have marked the whatever the 30 10 30 positive and shear is acting, you just see sigma x, this is acting anti-clockwise positive. So up 30 40 I have marked, this is over. First one 30 40 is over. Next 10 is also tensile, that's why I have marked here 10. And next what happened for this is clockwise. For sigma y this is clockwise, clockwise is negative 10 40 acting downward because clockwise is negative. Then what I did, I joined these two things with the help of scale and mark this origin. This origin is the Mohr circle origin. With the help of this origin we can consider this as radius and this as radius and construct a circle. The circle is called Mohr circle. Now I will tell you how to find major principal stress, how to find minor principal stress and how to find maximum shear stress. Okay, Mohr circle alli ena doubt idiya construct ಮಾಡೋದಕ್ಕೆ? Any doubts?
No, sir.
Okay, now see, this is the origin, right? This is O, this is O for x and y axis. From this O you just see the x axis where it is cutting. Okay, this point. So here to here distance, whatever here to this cut, this is sigma 1, your major principal plane. Approximately it is coming around 10 20 30 40 50 60 MPa. That is sigma 1. Sigma 1 approximately 60 MPa. You just see another cut is there here. Are you getting this one? This is minor principal plane, minor principal stress. This sigma 1 is major principal stress and sigma 2 is minor principal stress. And with the help of origin, what is the radius here? Whatever the radius, this height is tau max. That's all. So sigma 1, sigma 2, sigma 1, sigma 2 and tau max. So in Mohr circle, tau max equals radius of Mohr circle. Radius of Mohr circle. Radius of Mohr circle. Radius of Mohr circle. So any doubts? Any doubt idya idralli? With respect to x axis y axis nodbeko. ಯಾವ್ದು ಜಾಸ್ತಿ ಇದೆ? ರೈಟ್ ಸೈಡ್ ಪಾಸಿಟಿವ್, whatever, this is sigma 1 and remaining other part is sigma 2. This is major principal stress and this is minor principal stress, and whatever the radius, that is tau max, that is maximum shear stress. Keep in your mind, this will very important, direct question in Mohr circle construction. What is the maximum shear stress? They will give option, so on that option you have to pick radius of Mohr circle is the maximum shear stress. So these are the three things. By simple construction of Mohr circle we can determine easily. So any doubts?
Yes, sir.
Enappa?
Can you repeat how you got sigma 1 and sigma 2, sir?
Okay. See, you are getting one major axis, right? This one, x axis and y axis. With the reference axis only we have identified the points 30 40 as well as 10 40, right? This is the origin. So from this you have to measure whatever the cut on x axis where it cuts one circle. From you have to measure from origin to positive side. That is the maximum value. That is your major principal stress. And also similarly with the origin you are having one more part, that is the minimum value. So with respect to that distance, that is sigma 2. that is your minor principal stress. And with the help of this origin, whatever the radius, it may be this or this or this or this, the radius is same. So the radius is your maximum shear stress. The radius is your maximum shear stress. Sigma 1 is major principal stress. Sigma 2 is minor principal stress, major principal stress, minor principal stress, and shear stress. Clear?
Yes, sir.
Okay. Okay. So other students, ಬೇರೆಯವರು ಹುಡುಗರ ಏನಾದ್ರು ಡೌಟ್ ಇದೆಯಪ್ಪ? Any doubts?
No, sir.
Any doubts?
No, sir.
Okay, I will explain. See, in some cases, there is no shear stress. See, these are the very, very important and special cases. Generally, they will ask, students will commit a mistake easily in this particular parts. Okay, either the shear stress only normal stress kotro. How to construct Mohr circle? See, illi principal stress yeno ee tara ella keltare values. So in this case, it's very easy to draw. This is your y axis, this is your x axis. Say some value, say this is sigma x, and here you may get, because both are positive, you have to get positive. If it is compressive, you are getting in negative sign. Okay, I will do one thing, I will give this as negative. Okay, I will give this as compressive, sigma y. If it is sigma y, it will come on this side, right? Because both are normal stresses, we have to mark on x-axis. Both are normal stresses, we have to mark on x-axis. Any doubts? Any doubts? Any doubts?
No, sir.
Now there is no shear stress. There is no shear stress. What we have to do with this? See, say for an example, this is 40 and this is 10 compressive. So this 40 and this is 10. What is the total? 50. What is the center? 25. With the help of this, you have to take, this is the origin. So we have to construct a circle, that is Mohr circle. Now, what they will ask? They will ask, what is the maximum shear stress for this case? What is the maximum shear? Now, you can easily tell that tau max equals 25. Or they may ask, what is the maximum principal stress? What is the maximum principal stress with respect to origin? Whatever this cutting, this is sigma 1, and whatever you have least negative value cutting, that is your sigma 2. This is maximum principal stress. This is minimum principal stress or major principal stress, minor principal stress, and tau max. Tau max is the radius. Any doubts? Any doubts? Illa fast aita innonsari nidana kelbeka?
Sir, can you repeat once?
Yes, okay, no problem. Because this is very, very important topic. Repeat ಮಾಡಿ ಅಂದ್ರೆ ಮಾಡ್ತೀನಿ, no problem. But concept ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. One perfect question, 1 or 2 question definitely ಕೇಳ್ತಾರೆ exam ನಲ್ಲಿ. Okay. See here, what is the nature? Tensile, right? Tensile. First ಏನ್ ಮಾಡ್ತೀರಾ? ಒಂದು reference ಇಟ್ಕೊಳ್ತೀರಾ. This is x axis, this is y axis. Say I'm giving 40 MPa. 40 MPa. Graph ಇದೆ ಅಂತ imagine ಮಾಡ್ಕೊಳ್ಳಿ. 10, 20, 30, 40 MPa, right? This is 40. This is your sigma x. Next, I will give, okay, 20 I will give. 20. This is compressive. But what I told, normal stresses are always plot on x-axis. What are normal stresses? Sigma x and sigma y. So now I plotted sigma x. What is sigma y? 20. That is compressive. Compressive means negative. Say 10, 20. So this is sigma y. Any doubts? Any doubts? This is the origin. From here to here distance is 40 MPa. And here to here distance is 20 MPa. I just marked. There is no shear stress. On this case, nothing to worry. Hanganbit ನೀವು ಏನು ಇಲ್ಲ shear stress ಅಂತ ಬರಿಬಾರ್ದು. You have to take this. What is the total? 60. 60 by 2. 60 by 2. What is 60 by 2?
30.
60 by 2. What is 60 by 2? 60 by 2 is 30. 30. 30 andre somewhere here, right? This is 30, right? Here to here is 30. This is radius. So you have to mark this, and with the help of this, you take and construct Mohr circle. This is Mohr circle. You can easily say that this is 30. The radius is how much? The radius is 30. This is tau max, which is 30 MPa. And what is the major and minor principal? Here to here, whatever the positive value on x-axis, this is your major principal stress. It is also very easy. ಇದಕ್ಕೆ ನಿಮಗೆ ಗ್ರಾಫ್ ಎಲ್ಲ ಬೇಡ, ಈ ತರದನ್ನೇ ಕೇಳೋದು ನಿಮಗೆ. ಎಷ್ಟಿದು ಟೋಟಲ್ ಎಷ್ಟು ಸಿಗ್ಮಾ 1 ಎಷ್ಟಿದೆ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ 40. ಮೇಜರ್ ಪ್ರಿನ್ಸಿಪಲ್ ಸ್ಟ್ರೆಸ್ ಇಸ್ 40 MPa. ಹಿಯರ್ ಟು ಹಿಯರ್ ಡಿಸ್ಟೆನ್ಸ್, ವಾಟ್ ಇಸ್ ಮೈನರ್ ಪ್ರಿನ್ಸಿಪಲ್ ಸ್ಟ್ರೆಸ್? 20 MPa. ನಿಮಗೆ ನೋಡಿದ ತಕ್ಷಣ ಗೊತ್ತಾಗಬೇಕು. ಏನ್ ಗೊತ್ತಾಗಬೇಕು? ನಿಮ್ಗೆ ಏನ್ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀನಿ ನಾನು? Where the shear stress is 0, this itself is the principal plane. If this is itself is the principal plane, what is the principal stress acting? Sigma x is the principal stress. So the sigma x is which is nothing but sigma x value, which is nothing but that is your sigma 1. Whatever sigma y, that is your sigma 2. See, if you measure, that is minor. Why you get like this? Why you got like the ಏನಕ್ಕೆ ಬಂತು ಹಂಗೆ? ಏನಕ್ಕಪ್ಪ ಬಂತದು? ಏನಕ್ಕೆ ಅಂದ್ರೆ here there is no shear stresses. If there is no shear stresses, then this is the plane itself is the principal plane. Itself is the principal plane. Any doubts? Please see the problem. Any doubts?
No, sir.
No, sir.
Here, this is very important concept. See, ಈ ತರ ನಿಮ್ಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕೇಳ್ಬಿಡ್ತಾರೆ. ಸುಮ್ಮನೆ ಹೆಂಗ್ ಕೊಡ್ತಾರೆ? ನೀವು ಇದೆಲ್ಲ ಮಾಡೋ ಅವಶ್ಯಕತೆನೇ ಇಲ್ಲ. If you know the concept, principal stress, there is no shear stress. So major principal. So ಈಗ ನಿಮ್ಗೆ ಒಂದು ಸಿಂಪಲ್ ಆಗಿ ಹಾಕ್ತೀನಿ, ನೀವೇ ಹೇಳ್ಬೇಕು. I will give one like this. Okay. Say here I will give 30 MPa and here I will give 80 MPa. So now what I will ask, what is major principal stress and what is minor principal stress and what is shear stress? Direct agi ನೀವೇ ಹೇಳಬೇಕು. ಎಷ್ಟು major principal stress?
80.
Yes,
80.
very good. 80. What is minor principal stress?
30.
Yes, the nature is very important. This is tensile. And what is this?
Tensile.
Tensile, very good. What is tau?
40.
What is tau?
40.
Yes. How to compute tau? Not 40. How to compute tau? Tau is the
80
you have to-
divided by 2.
if you construct Mohr circle, what happens? It will come 80 here and it will come 30 here, right? Because both are positive, right? 80, 30. Now, what is Mohr circle? You have to take it center. What is the center? In between 30 to 80, how much gap? 80 minus 30.
55.
50.
What is 50 by 2?
25.
Yes, that is very important. What is tau value? That is the radius. Yes, right? Have you got the concept? With the help of this radius only, you are going to construct the Mohr circle. Now, what is tau max? Tau max is this radius. And now, what is the major and what is the minor principal stress? See, if you measure here to here, that is sigma 1. What is sigma 1? 80. If you measure to here, what is sigma 2? 30. See, without knowing the formula, you can judge the answer in a very fast manner. That is the secret of Mohr circle. So, any doubts? So, we have discussed a very important concept. If you know the concept, by trial and error method, you construct a Mohr circle within 1 minute or 2 minutes, you can judge the answers easily. Now I will take another case. See, this is the Mohr circle. Now what I will do? I will give pure shear. There is no normal forces. I will give 40 MPa. Here also same. You are getting a pair, right? 40 MPa. Now, What is the case? See, try to construct x, y. In x, there is nothing, right? But 0, right? Nothing means 0. So you are having plus 40, minus 40. So with the help of this, construct a Mohr circle. Now with the origin, whatever the thing you are getting, this is positive sigma 1, sigma 2. This is tau max. Now tell me, what is sigma 1 value? What is sigma 2 value? And what is tau max value? Yes, what is sigma 1?
40.
Yes, very good. What is the nature?
Tensile.
Tensile, very good. What is sigma 2?
Minus 40. 40
Yes.
MPa compression.
Yes, very good. Compressive. What is shear?
40.
40.
Yes. See, these are the very important. It's a pure shear. This is called Inama?
40
Yes, 40 right side ಇದು ಬಂದು ಫಸ್ಟ್ ಕ್ವಾಡ್ರೆಂಟ್ ಆಗಿರೋದ್ರಿಂದ ಅದು ಪಾಸಿಟಿವ್ ಟೆನ್ಸೈಲ್ ಆಯ್ತಮ್ಮ. ಇದು ಬಂದು ಸೆಕೆಂಡ್ ಥರ್ಡ್ ಕ್ವಾಡ್ರೆಂಟ್ ಆಗಿರೋದ್ರಿಂದ ನೆಗೆಟಿವ್ ಆಯ್ತಮ್ಮ. ನೆಗೆಟಿವ್ ಅಂದ್ರೆ ಕಂಪ್ರೆಷನ್ ಆಯ್ತು. ಕ್ಲಿಯರ್? Any doubts?
Sir, can you explain it again, sir?
Okay.
No confusion.
See, this is a state of pure shear. There is no axial or normal forces. There is no normal or axial forces. You know that. Simply you take x-axis, that is y-axis, and x-axis. Okay. What is sigma? Sigma, there is sigma is 0, right? Sigma is 0 means here. Sigma is 0 means here only, the point. What is tau value? This is anti-clockwise. Here in x, this is anti-clockwise positive. So 40. Here clockwise negative. So 40. Once you mark this, what is the center? This origin is the center. With the help of this center, construct a Mohr circle. If you constructed the Mohr circle, you know that whatever this cutting part, here to here distance, this is the major principal stress. So always positive. Or always, not always positive, generally that's a positive case. Sigma 2. And whatever the radius, this is tau max. Now tell me the values. What is sigma 1? What is sigma 2? And what is tau max? Yes? Hedama, enama sigma 1 enilli?
40, sir.
Yes. It is positive or negative?
It's positive, sir.
Hence tensile. Next, what is sigma 2?
It's minus 40. It's compressive in nature.
Yes. Then what
Yes,
is
sir.
tau? It is 40.
It's 40.
See,
Yes, sir.
don't waste your time. If they give whatever the thing, the only thing you have to be careful is compression and tension. They will give the answer like for 40 MPa tension, 40 MPa tension, 40 MPa compression. They will confuse in answers. Okay. So now what I will do, I will give one reverse case. I will give the reverse case. See here. Reverse case. I will give 50 MPa. 50 MPa. Now tell me what are the values? What are the values of sigma 1, sigma 2, and tau max? Yes,
50.
please try to get the answer. What is sigma 1?
50
And
MPa.
what is sigma 2? And what is tau max? In 1 minute, you have to say what is the answers.
50.
That's 50.
50.
Sigma 1.
50. Yes, 50 is the answer. That is right. Obviously, 50 is the answer. But nature, sigma 1, whether it is positive or negative.
Compression.
Negative.
Negative.
Tension.
Compression.
Tension.
As
Compression.
The thing is 50
Tension.
MPa compression, 50 MPa tension,
Tension.
and this is 50 MPa nothing. This is one set of answers. Another set of answer is 50 MPa
50 MPa
tension, sigma 2, 50 MPa
compression.
compression, and 50 MPa. Which one is right? Whether the first one is right or second one is right?
Second
Second
one.
one.
All are going with second?
Yes, sir.
Yes, sir.
Okay. Now
Which
I
one?
will try to get the thing. Okay. Okay. This is y-axis, right? Now, you take any set of the thing, no problem. For this 4 sigma x, how it is rotating? 50. How it is rotating? 1 is 50. Now plot the circle. Then tell me what is sigma 1? Whether it is compressive or tensile.
Tension.
Why you told like compression? This is this is the problem. See, that's why so many times never with the thing is ಏನು confusion ಮಾಡ್ಕೋಬೇಡ್ರಿ, simple graph plot ಮಾಡಿ, because it's in equilibrium. So what I told, generally maximum value, whatever you are getting, if you construct a circle, you are getting tensile nature only. This is compressive nature. So which one is right? First one is right. This is wrong. So your whatever the sign convention, you are getting the same answer. ನೀವು ಅದಕ್ಕೆ ಸಿಂಪಲ್ ಆಗಿ ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಮಾಡ್ಕೋಬೇಕು, ಸಡನ್ ಆಗಿ ಹೋಗಕ್ ಹೋಗ್ಬಾರ್ದು ಆನ್ಸರ್ಸ್ ಗೆ. ನೋಡಿ ಹೆಂಗ್ ತಪ್ಪುಗಳಾಗ್ಬಿಡುತ್ತೆ. ಸೊ ಅಲ್ಲಿ ನಿಮ್ಮ ಮಾರ್ಕ್ಸ್ ಹೋಗ್ಬಿಡುತ್ತೆ. ಸೊ ಇವಾಗ ಏನು ಯಾವ ತರನಾರು ಕೊಡ್ಲಿ, ಎನಿ ಸೆಟ್ ಆಫ್ ಶಿಯರ್ ಕೊಡ್ಲಿ, ಆಲ್ವೇಸ್ ಸಿಗ್ಮಾ 1 in tension, sigma 2 in compression, and tau you are getting the value, whatever the value you are getting. Any doubts? This is the very, very important concept. Any doubts? ಅರ್ಥ ಆಯ್ತೇನ್ರಪ್ಪ?
Yes, sir. Yes, sir.
ತಪ್ಪು ಮಾಡಬಾರ್ದು. ಅದಕ್ಕೆ ನಾನು ಸ್ಪೆಷಲ್ ಕೇಸಸ್ ತಗೊಂಡಿದ್ದು, ಕಾನ್ಸೆಪ್ಟ್ ಅರ್ಥ ಮಾಡ್ಬೇಕು ಅಂತ ಇಷ್ಟೊಂದು ತಗೊಂಡಿರೋದು. ಹೇಳಪ್ಪ. ಎಸ್ ಕ್ಲಿಯರ್? ದಿನೇಶ್ ಕುಮಾರ್, ಎಸ್ ಹೇಳಪ್ಪ. ಎನಿ ಡೌಟ್ಸ್? ಓಕೆ. ಓ ಸಾರಿ. ಓಕೆ ಪಾ. Next, okay. So with this concept, I just going to glance some of the MCQ. So any doubts? Okay, any doubts? Yes, why bidbeku, artha aita artha aglilva?
So can you just illustrate another example with both shear and stress acting?
Only pure shear or combination of both?
Combination of both.
Very good. Okay, we'll take the combination of both. Sir, we are having time. How much you are having time? 5 minutes. Okay, I will try to finish in 5 minutes. Which case you want? Combination of compression and tension or both compression?
It's a combination of compression.
Combination of tension and compression.
Stress and shear. Combination of stress.
Both are compression.
Anything is fine, sir. But I just want to know what it's like to have both shear and stress.
Okay. Okay, I will give all are in compression, no problem. And also shear. A set of shear. Okay. See, you can take any value, 40, 30, 20. Okay. If you take, this is the y-axis. Briefly, just take the x and y axis. It's not respect to scale and all. Okay, what is sigma? What is sigma x value? What is sigma x value?
40.
40. Compression or tension?
Compression.
Compression. So 10,
Negative.
20, 30, 40 here. Okay. Now at 40, so this is the thing. How the shear stress is rotating? In which direction?
Clockwise.
For this 40, this 20 is how it is rotating?
Anti-clockwise.
Anti-clockwise. Positive or negative?
Positive.
Positive. What is the value?
40.
10, 20 here, right? So this is 10 and this is 20. On a graph sheet we have to plot. So this is approximation 40, 20. Similarly, now I will come to second thing. So this is 30. Where it come? 30 means 10, 20, 30 here. This is also compression. That's why at 30, 20, how it is rotating this 20? Clockwise. Clockwise is positive or negative?
Negative.
Negative.
Here. So this is sigma y comma tau xy. So sigma y is 30 comma 20. So this is sigma x comma tau xy. Sigma x comma tau xy. Now you have to join these two things with the help of a scale. So this is the origin. This is the center point for Mohr circle. With the help of this, you have to construct a circle. With the help of this, you have to construct a circle. So this is your Mohr circle. Now, see, in this case, this is the thing, here to here distance. This is major principal axis, here to here distance. This is minor, and what is the radius? Here to here distance. This is tau max. So for this, all compression force, sigma 1 is also compression, sigma 2 is also compression, and tau, you are getting the value. So any doubts?
No, sir.
Any doubts? Clear? For shear stress, you are getting sigma 1 tension, sigma 2, again it depends on, that is also in compression, and tau value you are getting. Clear?
Yes, sir.
So we explained so many examples, see, and also we explained the analytical equation. This is the concept of two-dimensional compound stresses as well as Mohr circle. So any doubts? If you're having any doubts, please ask me without hesitation. I will try to clear all of your doubts. Okay. So see, and now I'm coming to presentation part. See, this is the Mohr circle, but don't think about this particular aspects. Whatever I have given, that is enough. So clear? Any doubts? Clear
No, sir.
concepts?
Yes, sir. Yes, sir.
Clear
Yes, sir.
idea? Okay. Okay. In MCQ, see, I will take only one question because only 3 minutes left. Yes, I will take this question. ನೀವೇ ಹೇಳಬೇಕು, ಬೇಗ ಪಟ್ ಅಂತ ಹೇಳಬೇಕು ಇದಕ್ಕೆ ಆನ್ಸರ್. ನೀವು ನೋಡಿದ ತಕ್ಷಣ ಹೇಳಬೇಕು ಆಕ್ಚುಲಿ ಕ್ಲಾಸ್ ಆದ್ಮೇಲೆ. This is the given. Yes, what is the maximum principal stress? By looking the diagram,
18.
ಪಟ್ ಅಂತ ಹೇಳಬೇಕು.
18.
Very good, 18. So this is the maximum, sigma 1, right? Now, what is the minimum principal stress?
-8.
8.
Minus
Yes,
8.
very good, sigma 2. What is the maximum shear stress?
It's 13. 13.
Yes, for shear stress, what you have to do? Take the radius. What is the radius? Where it comes? 18 plus 8, how much? 18 plus 8, 26 by 2.
26.
13. Where is 13? Tau max. Now, I will give the code. Which code is correct? Which one? Which code?
D.
425. So B. So it's over. So how to compute this normal shear stress on the plane? It's very simple. Sigma 1 minus sigma 2 by 2. Shear stress is sigma 1 plus sigma 2 by 2. So that's why 18 minus 8 by 2, 10 by 2. 10 by 2 is 5. This is normal shear stress. Any doubts? So these kind of problems they will ask. So by looking the thing, you have to immediately have to do the things. So waste the time. So anyhow, sir, time to take one more problem. So because another 2 minutes are there. Okay, here. Yes, very easy. Radius of Mohr circle stress 20 Newton per mm square, and minor. Yes, what is the major? See, he is given sigma 1. He is given sigma 1. 10. He is given radius 20. What is sigma 2?
It's 30.
30.
30.
Any other answers?
Sigma.
Yes, sir. 30.
See, sigma 2 is 10. What is sigma 1? 30. Fine.
50.
Any other answers?
Yes, sir.
Yes. What is the thing?
50.
Tau
50,
equals
sir. 50.
sigma 1 plus sigma 2 by 2. Tau. What is tau? Tau is given or not? Radius. Tau is radius, right? Radius is nothing but tau in Mohr circle, right? So 20 equals sigma 1 plus 10 by 2. So 40 equals sigma 1 plus 10. What is sigma 1? 40 minus 10. How much?
30.
Yes.
30.
Someone told it fast. Very good. See, this is the type of question you can expect. Indirect question, direct question. Clear? Okay. Thank you. So let me take a few more examples in next class. Thank you very much. All the best. Thank you, Pa.
Yes, sir.
Thank you, sir. Thank you, sir.
Thank you.
Thank you, sir.
Thank you, Ma.